Okay, so you have, all of you have done some amount of work with sound or connecting things together and plugging stuff up and putting systems together, right? Everyone's done at least a little bit of that sometime in their life, or you would never have found us. And although that experience varies from person to person, I would be willing to bet, I'm going to give you a little example, and tell me if this doesn't match your experience. Sometimes, or maybe a lot of times, things don't work when you put them together. Or maybe they work one day and then the next day they don't work. In my experience, most of the time, stuff doesn't break. Like the equipment itself doesn't break very often unless it's like dropped from high up in the air and crashes onto a ground or gets run over. But it doesn't break just sitting still, usually. Right? Something like it worked yesterday, it's not working today, it didn't move, probably didn't break, right? So the fact that it's not working is not that it's broken. What tends to happen after you eliminate the possibility of you just, making some kind of mistake, which that happens. So barring mistakes on your part and dropping stuff, the most common thing to go wrong is a cable or a connector. Right? A cable gets cut, or a connector suddenly doesn't connect, or doesn't work out right. It's the cables and connectors that are the finickiest part of what we do, and because they can get yanked, the soldering job might be bad and can come loose. You might have stripped the jackets too much, and so the wires touch inside. You twist that cable just right, and now it shorts out. This is why I had you all make a cable checker last semester, because you're going to spend your life checking cables, because those are the things that get messed up the most, okay? That's probably, if you think back to your experiences so far, you would probably realize that's true, right? That most of the problems when things don't work, it's either bad or wrong cables that might even not be connected to the right thing, right? Here's the problem, though. In a given sound system, the thing that you have the most of are cables and connectors. Right? That's the thing that you have the most of in your system. So it's this really frustrating part about what we do, which is that the thing that is the most flaky in your sound system just happens to be the thing you have the most of. I wish we could flip that so that the flakiest thing was the thing you had the least of, but it's just not the case. The cables and connectors are the things that will disappoint you the most, and those are the things that you have the most of. In any given system, you could have hundreds, if not thousands, of connectors in your system. And each of them is like this thing that is very temperamental and works sometimes and then doesn't work other times. The good news is you now know how to fix cables, because I taught you how to make them. You know how to test them, because you built a cable checker. So that's all great. You can test them and you can fix them when they're broken. But how do you figure out which ones to test so that you know which ones to fix? Well, when you're doing a system diagram in AutoCAD like we've done so far, there's little, if any, information about connectors in there, right? That diagram is just showing that this thing connects to this thing, but it doesn't really explain how. There's just a line drawn between those two things, that this thing plugs into this, but it doesn't explain how that happens, what kind of cable you're using, what kind of connections it is. You could add all that information to your system diagram if you want. The diagram guidelines I showed you include provisions for that, but in a complicated drawing, system diagram, if you're adding that amount of labeling to every line, that's going to get really cluttered very quickly. And it'll make that system diagram harder to read. So what I prefer to do is put that information in a separate drawing that I call a patch plot. And the patch plot accomplishes a few things. First of all, it tells you actually how everything connects together. Not just what connects to what, but how it connects. Meaning, like, this thing connects using an XLR to 1/4 inch adapter cable. Okay? Or this thing connects by going through a patch bay. Or there is some wire running in the walls as part of this signal. And your system diagram may not tell you that one of those purple lines is actually inside of a wall. It doesn't tell you that. But knowing that is really important because now you got to figure out, well, how do I access that cable that's inside of that wall? So the system diagram tells you what connects to what. The patch plot tells you how it connects. It also tells you, if you do it right, it tells you where every single one of your connectors are. And because the connectors are the thing that will fail you the most, you really ought to know where they all are. Because in a given path of signal, if you think about the thing that makes the sound, that generates the sound, that ultimately goes through a whole bunch of things and connections before it gets to a loudspeaker that then reproduces that, how many connectors are in that path? 10, 20, 30 maybe? If any one of those goes bad on you, it doesn't matter that all the other ones work. That one connector takes that whole path down. Okay? So you really want to know where every single one of them are. So when that path isn't working, when that particular signal path isn't working, sound is being generated on this end, but it's not coming out on this end, you know where all the connectors are, so you can check every single one of them, because odds are one of those connectors has gone bad some way. Either the connector's broken or something got unplugged or whatever, but you got to go trace it and figure it out. So that's what a patch plot does. And a patch plot, you draw this in CAD. You're going to do this using a spreadsheet, okay? So I'm going to show you how to do that. And this is the one I'm going to have you draw, okay? But let me show you what we're going to do. We're going to do this in a spreadsheet, and I would highly, highly recommend. I know that you all are the Google Docs generation, and I understand why, because that's what the schools gave you, right, when you were in school. I get that. And you had the little Chromebooks, and they gave you all Google accounts, and you had this access to Google Docs and Google Sheets and all that, and I know that that's what you're comfortable with. And those are great for that. But there are very significant limitations to what those tools can do for you, especially in the context of how pretty you can make it look and the formatting you can do. So I would highly, highly encourage you to do this in Microsoft Excel, okay, which you have free access to through your Student Outlook account, okay, and you can actually download that app to your computer. Highly recommend that you do that. You can do this assignment in Google Sheets if you really, really want to. You can. It is possible, but it will be harder. All right, so here is the system diagram that I need to do a patch plot for. This is from an actual show I did. All right, so here's the drawing. It just tells me, what connects to what, doesn't explain how. I got to figure out how. So some of this is I got to go over to the space where we're doing it and figure out, well, what kind of wiring's there, what kind of wall panels are there, what kind of stuff's running in walls, where are the patch bays. And I'm not expecting that you will understand all of that at this stage of the game. You will get the opportunity to kind of learn and experience that when you do it on a show, right? You'll figure this out. So a lot of what I'm going to show you, you're going to be like, how did you know that that's what the connector was? Because I went and looked at it in real life and I figured it out, okay? And I'm not going to replicate that process right now. But that's what you will do in real life. Like, you will draw this out and you will know what needs to go, how it needs to go together. And then you're going to go look at the real stuff in the shop and you're going to actually have to plug it in. And you're going to realize that, oh, I need an XLR to 1/4 inch adapter. And so now that you know that, you can then put that in your patch plot so that you know that you need it. So let's talk through it here. Here is the actual thing. So here's what I'm doing. I'm going to take you through some conventions here. And I want to emphasize that I made this up. Okay? You can ask me why things are the way they are, and the answer will be because I made it up. And that's what I thought made sense. And that's as good of an answer as I can give you, okay? I made this all up. So, one of the things that you're going to want to do is use color or shading to your advantage to help, because otherwise this is going to be impossible to read. It will be just a bunch of text in cells on a spreadsheet, and you won't be able to understand it. So the first thing is equipment, like a piece of equipment that is would sit on a shelf that you would plug into power or something, or like a microphone or a mixer or an amplifier or a loudspeaker, like an actual piece of equipment. That should be gray. Okay. If it is a wall plate connector, so by a wall plate connector I mean like this, where there's these little Ethernet connections on a wall. That's a wall plate. Like, there's wire inside of a wall somewhere, and we have a little box on that wall that's got a connector on it that lets you access it. That's a wall plate. Okay, so if you're drawing a connector that is attached to a wall plate, that should be, I would describe this as lavender, as opposed to purple, because I think purple would be a little darker than this. And you got to be careful how dark you let these colors get, because you don't want it to shade the text too much so that you can't read the text, right? So I would say lavender, but as long as it's some sort of like flavor of purple, that's fine, as long as you can read the text on top of it. And here's the thing, because I made this up, you might be tempted to be like, well, this is all made up anyway, so I could just pick different colors that I like. Don't do that, because the only way that this drawing means anything to anyone is if we all agree on what the colors mean. Okay? So if everybody decides that a wall plate is a different color, then how do I look at somebody else's drawing and know where all the wall plates are, right? So try to resist the temptation to get too creative with the colors, okay? We all have to be on the same page about the colors, or we don't get to look at each other's drawings and know what they mean, okay? If it is a patch bay, and a patch bay, you might have seen these in our spaces, but all these, when you have a wall plate, and here's this wire, you can see it's going through this channel. Well, where does it go? Well, it goes up into the ceiling, and it rolls around up there, and then eventually it shows up in this building. There's a closet back here at the end of the hall, and in that closet is a rack, and it's just rows and rows of connections, which represent the other end of all of these cables that are on these wall plates that are spread out all the building. So every individual wall plate has a cable behind it that ultimately goes back to somewhere, okay? And they all go back to the same place, usually. There'll be some little rack panel somewhere that just has rows and rows and rows of connectors that are labeled. So there'll be two that are labeled MacLab, DMP 120, G40, and G41, which is what this wall plate's labeled, okay? But then right next to it will be DMP 120, G42, and 43, which is probably over there somewhere, right? And those will all be in a row, okay? That's called a patch bay. So if the connector you're talking about is in a patch bay, then it should be blue, some sort of light blue, like this, okay? Everybody with me so far? Okay. If it is a snake, and you may not know what a snake is, so I will explain. So we know what one cable is, right? You made some. But sometimes we will, in order to save ourselves a lot of hassle, if we're running 12 cables, all from the same place to the same place, rather than lay 12 individual cables, we will buy what's called a snake. And that snake is this big, fat cable that actually has 12 individual cables inside of it, but we can coil it and work with it like it's one big cable, and it just like fans out to the individual XLRs or whatever it is on either end. You may have seen these things in your life. They would call them snakes, okay? Because, it looks a little bit like a snake, because it's, it's thicker than like an individual cable. Big snake, okay? If it is a snake, it should be yellow. Why? Because snakes are yellow.
Everybody knows that.
It's like chess. You can't explain in chess why the knight gets to move in an L shape and nobody else does, right?
But he sure does get to move in that L shape.
But that's how it works, right? Somebody who decided that that's how that works, okay? Okay, the last color thing that is significant is if you are labeling a cable, and if that cable is something that it is possible for you to pick up the entirety of that cable and leave the building with it, it should be red. That label should be red. So when you see like this, which says XLR, cable, XLR, that means that's an XLR cable that is not attached to the building. Like I could, if I wanted to, unplug it from wherever it is and I could leave with it. You couldn't leave the building with the cable that's running inside the wall, right? I mean, I guess you could, but it would require tools, right, to remove it from inside the wall. So the point here is, if it's possible for this cable to leave the building, then it's possible that cable might not be in the building, right? And if it's possible for it to not be in the building, then you need to know that you have to make sure that you bring it. Because if it's possible for it to leave the building, that means someone has to bring it to the building as well. So everything that is red is usually, that means that's something I have to bring with me, because it might not be there. Now maybe it's there. Maybe there's maybe there's a little XLR patch cable already over there in the space, in the booth somewhere. Maybe, but it's possible that it's not, because somebody could pick it up and leave the building with it. So I'm going to label that in red so I know that's something that I have to make sure is there. I can't assume that it's going to be there, because it's possible for it to not be there. Okay, so you do that in red. Those are the color things you need to be worried about. Again, you just accept that and run with it. I don't think I'll give you too terribly hard of a time as far as your shade of yellow, purple, or blue. other than, you know, like if I change this, for example, to that purple, well, that's hard to read that label now, right? So this is what I mean by you have to think about that. Okay, so that's why I went a little bit lighter. Okay. So here's what we do. Let's just like look through this system diagram now. So I have these Shure ULX wireless microphone receivers. I did not draw the transmitters in my patch plot because they don't actually patch, right? They're like not connected to anything. That's the whole point. I don't have to plug them into anything for them to work. So it's not super important for those to be on my patch plot. But the receiver definitely has to plug into something. So I'm going to draw. So here's now on my system diagram, I just drew receiver with a line directly going into the mixing console. But in real life, I know that the back of that receiver is an XLR connector. And so I'm going to draw the ULX 1, 2, 3, 4, 5, 6, because I have 6 of them. And on the back of that, there's a label on that connector, and you want to draw that, you want to write that label. Whatever the little printing is next to that connector that labels it, you want to have that in your patch plot. So that, because there might be more than one on the back of here, and you want to make sure that you know for sure which one you're plugging this into. So in this case, it's labeled mic out. So I made a cell that just said mic out. And then next to that, I put the connector. Now, I did this show, I don't know, 10, maybe 12 years ago, maybe more, I don't remember. And you want to be specific about the connector. There's been, for the longest time, we described connectors in terms of male and female. And the manufacturers still, for the most part, do that. But if you notice in the USITT specs from 2022, they're sort of recommending that we get away from that for a couple of reasons. But one of the reasons is that description is not actually always clear on all connectors, right? I mean, but also, it's a little weird that we're assigning gender identities to inanimate objects. That's a little weird. And we didn't really think of it as weird until until someone was like, hey, isn't that weird? And everyone's like, yeah, that is kind of weird. Why do we do it that way? That's kind of silly. So we're in a bit of a transition period right now on that, because like we have industry standardization organizations that are saying, hey, maybe we should like do this a little bit differently. But the manufacturers haven't quite caught up to that. So you're going to see, like Neutrik, for example, still sells XLR male and XLR female connectors. But the USITT recommendations suggest that you use the terms pin and socket. And so I'm showing you this male and female because that's how I did the drawing initially. You can do it that way. If you want to change it to pin and socket, that's fine too. I don't really care. I will accept either. Because at the moment, we still haven't like fully landed this plane. We're still having that conversation. But this XLR-M would be an XLR-P for pin, and the XLR-F would be an XLR-S for socket, okay? So you can do that if you want. That does seem to be, we're going to end up there eventually, because that's where we're pushing the manufacturers. They'll get there because they'll realize that that's what everybody's doing, but they're just not there yet. So at the moment, you're still ordering male connectors and female connectors, but calling them pin and socket. So at this point, either is acceptable in terms of a drawing because it is technically accurate. Okay, so, but you want to be specific because there's more than one kind of XLR. Now, for our purposes, the most common XLR we use is a 3-pin XLR. So you can assume that that's sort of the default. And if it's different from that, then you would add that information there. You would say XLR, like if it's a 6-pin XLR, you would say XLR6P or XLR6S for socket, right? So that we know that it's a 6-pin. The important part in a patch plot is that you know that connectors always touch connectors. So you should, if you ever write a cell on your Excel file that has a connector in it, there should always be another connector in the cell next to that, because that's how cables and connectors work. You plug them into each other. So you want the label here, then the connector, then the next connector, and then the label for that connector. So the connector is always touching the connector. Okay? Now what I'm using here, because I have these 6 receivers that I'm then connecting to my mixing console, which is a Yamaha LS9. So I have the Yamaha LS9, and then I have a cell representing the label for each connector, and the label is IN27 or IN28. That's what it says on the back of it. And then I have an XLR connector that's attached to that label. Well, then I'm using a snake. I found a 6-channel snake that was all one big thick cable that fanned out to 6 XLRs on each end. Okay? So I'm drawing snake. Now I merged these cells together. Do you know how to do that? So I could say it's a snake. And I could select all of these. And let me drag this out. And I can click this merge and center. And then you can position it there. You can change the text to red, and you can bold it. And then you could do the 1 there. Now here's a little tip. Instead of typing each number, if you just grab this little handle and drag it and hold down the Option key, it will automatically increment them for you. Option key. Okay. And then you can do the XLR. This would be the socket. And then you can just drag it down, it'll copy them. See, you don't have to type them all. And this will be the pins. So you don't have to hold the Option key this time because you're not asking it to change a value when you drag it. And then I could select all of this, and I could shade it as some kind of yellow. And I'm going to make sure I use the same yellow, so I use the little dropper there. There you go. And then I'll turn on the grid lines. See? I made a snake. Everybody follow that? That make sense? Okay, so you're going to kind of work your way through this, and you just keep going through the whole system. You start with the system diagram, and you just sort of figure out, okay, well, this one line, like, what does that actually represent? Oh, well, it turns out I'm going to use a snake, and it's XLR, and there's, you know, I know which direction it needs to go and all that, so you're going to draw that out. So I don't need you to fully understand this full patch plot and what all these things are, but I do need you to take some time to practice making this in Excel. Okay? So you're going to go and you're going to make this whole thing, and I'm giving it to you here. This is the final thing. Now, what I usually do is I will first draw it as one big long thing like this. Okay? Just because I don't know yet how I'm going to make it fit on paper. So I just do it as one big long thing. And then when I am ready and I think it's right, then I start figuring out how it fits on the paper. Now, this is where Excel is going to be your friend, and this is where Google Sheets is going to disappoint you. Google Sheets is really terrible at page layout because they're assuming that this is never going to see a piece of paper or even a virtual piece of paper. It's always just going to be sitting there as that Google Sheet. And so the printing and plotting and page layout features of Google Sheets are really, really disappointing. So let me show you what you're going to do. First, you're going to select all of this drawing. Oops, hang on. All of the things you made. And then you're going to go to File, Print Area, and do set print area, meaning this is the area of this sheet that's going to be printed. Okay? And then you can go to the page setup and you can kind of get a sense of what kind of, well, hang on. We go to print. Did they move this? I might have to do it here. So you might have to go to the page layout here to pick out your paper size. So I picked 11 by 17. And because I've done that, you see these little dotted lines that it's created now? Can you see that on the projector screen? Yeah, okay. So that's where the edge of the page is. So it's kind of giving you some indication of kind of like how it would have to divide this up into different pages. And so what you're going to want to do is try to keep it within those bounds. And this is a matter of like saying, okay, well, if that's where the edge of this thing is, then let me get rid of this because I didn't want that there. And no borders. Okay, and unmerge. So when you're gonna like take this and move it to a new line, you need to think about where you're gonna do that from, because it needs to be from somewhere that makes some sense. And you want to repeat it. So if you look at my example here, I found a place to separate it where I could end it there and then pick it up where it left off, and I repeat those cells down here. So I know where I picked it up, and you want this to be some uniquely identifiable thing. For example, I wouldn't want to do it here, because when I take that and copy that down here, well, that could be any 6 XLR connectors. How do I know for sure where I left off, right? So it should be something that is uniquely identifiable. And this is uniquely identifiable. There's no 2 cells that look exactly like that anywhere else in this drawing. So what I do is I take this and I just sort of go and select all the way or back here, get the whole thing. I'm just shift clicking to get more. And I copy. And then I go down here and I paste, right? And then I can go over here. Once I've got it, then I can select everything except the part I'm going to repeat, and I can clear that out. So I just right click and do clear contents, no fill, no grid lines. Then it goes away. Then you might need to go ahead and add the side grid line back in here. Okay. And then I could keep going. Okay, now where else do I want to repeat it? And eventually I will end up with something that looks like this. And I know that this should fit reasonably sized on an 11 by 17 sheet of paper now, because I more or less stayed within those dotted lines. And then I added a grid line here to this row that was kind of a thick grid line, a thick bottom grid line. And we can do that here by doing a thick bottom border. And that just creates that line to make it clear that we've started a new line, okay? Yes?
If we were to start with the fourth one,
With the fourth one, what?
with the fourth row, would we, is that normal with the like separate columns that you have for that one?
I don't understand.
Like, with how close they are together, is this more like something that you would know and like know how to identify?
What part are you talking about?
At the very beginning, where it ends on the third, and then
Here?
yes. Oh, no, on the very,
Here.
yes, yeah, that one. Like, is there a reason why you chose that one?
Oh, well, just because I didn't want to do it here, and I didn't want to do it here, and I didn't want to do it here or here either. So this seemed like the most likely thing that I could repeat that I wouldn't get confused about. So that's just, now if you go find that spot over here, it was this, right? Now, one of the things that you will notice as you start pasting this stuff around is that the widths of things will start changing. And if you go up here and just double click on this edge here, it will automatically size that column to fit the contents. You can also notice that, like here, in order to make this not have to be so large, I've done this wrap text option, which if I don't do that, it looks like this. And to make that all fit, I would have to make it that wide, and maybe I don't want to do that. So instead I can say wrap text, and then I can adjust it like that so it's not so big. Okay. So once you get it all laid out and it's feeling good, then what I would suggest at that point is now you do a set print area. This is the very important part, so make sure you're paying attention. So I'm set the print area, and then I'm going to go to print, and I am going to send this as a PDF. Okay, and you'll need to have some kind of printer selected for this that'll do this sheet size. So you may need to just like add a fake printer that you know is got that kind of page size on it. If you need help with that, let me know. But then what we're going to do is we're going to save this as a PDF from here. Okay? And then we can put it wherever it is. And we will end up with this. Okay, so that's the PDF, right? Well, guess what? In AutoCAD, I can stick that in as what's called a PDF underlay. Now, the idea here behind the PDF underlay feature is this would be a file. You would put this as an underlay in CAD, then trace it. But you can also use it to do the layout. So you could pull up a layout, and instead of doing a viewport, you could insert a PDF underlay. And let me go get that file now. There it is. And I'm going to say attach and insertion point there. And then I just kind of have to decide how big I want it to be. Probably like that. Then you can insert your title block on there. And then that'll plot together with all of your other drawings. The important thing to remember is this is basically a reference file. So you didn't actually import this. AutoCAD is pulling it live from wherever you got it from. So you have to move this DWG with that PDF file everywhere you go. Okay, so just heads up on that. But eventually, you can make it look like this if you manipulate the size of it and put your title block and everything, and then it plots like every other drawing in your package. Okay. So here's the assignment. Recreate this patch plot, just like this, using a spreadsheet program such as Excel. You can do this in Numbers. You can do it in Google Sheets. I would not recommend it, but if you want to try to, knock yourself out. Numbers is really good at making things look pretty. Really good at that. But there are other eccentricities that it has that make other things harder. Google Sheets is convenient and free, but really, really not great at this page layout piece of it. So, I'd really recommend you start learning Excel. You're going to use that for other things too. But I will let you use whatever you want. I just really want the end result. Okay? So you're just going to make this. And the main point here is I just want you to practice wrangling a little spreadsheet app to make something that looks like this. Okay? Later, probably next year sometime, when you're doing a real system, you'll have to do the other part of this, which is figure out what information has to go in all these cells. And that'll be part of that. That's when you figure that out, is then. Right now, I just want you to get comfortable using something like Excel as a drawing tool, which is not something it's like really supposed to be used for, but it does let us do this, and it works. Okay, so I want you to get used to using it to do that. Any questions? Remember, don't do it the hard way. You don't have to type every single cell, right? You can, if you need more of these, you just, look, I got a whole bunch of XLRs there now, okay? Use some of these shortcuts to your advantage, all right? Do it the efficient way.
How did you add in the lines?
So I would select this set of cells, and then I would do thick bottom border, and it would put it there. Yeah? Any other questions? All right, you have about an hour that you can get some significant progress made on this, okay? If you need help, let me know, and I will come and help you.